Hello everyone, welcome back to the channel Future Force. Please subscribe and like my videos. Today we are going to explore one of the most shocking events in the ongoing conflict between Ukraine and Russia, the Ukrainian drone strike on the Rosneft refinery in Ryazan. This event not only disrupted one of Russia's key energy infrastructures, but also sent waves of shock across the global energy markets and political circles. To understand the depth of this incident, we must examine the entire scenario in detail, from its external visuals to the internal mechanisms, the performance and resilience of the facility, the safety measures that were in place, the unique aspects that make this strike significant, the cost inflicted on multiple levels, and finally, what it means for the future of industrial security in times of modern warfare. From the outside, the Rosneft refinery in Ryazan is a massive and complex industrial landscape that stretches over a wide area, with its network of pipelines, processing units, towering distillation columns, and storage tanks creating an industrial skyline. It is a facility that represents decades of investment, technological advancement, and strategic importance for Russia's energy supply chain. This refinery is a major node in refining crude oil into valuable petroleum products such as gasoline, diesel, jet fuel, and lubricants, serving both domestic and export markets. The exterior perimeter is fortified with fences, security gates, surveillance cameras, and watchtowers, reflecting the strategic importance of the facility. However, on the night of the Ukrainian drone attack, this exterior turned from a symbol of industrial strength into a vulnerable target. Flames rose high into the night sky, black smoke billowed over the region, and the silhouettes of the refinery's structures glowed ominously against the inferno. What was once a site of steady industrial operation became a fiery spectacle, drawing the world's attention and signaling that no infrastructure is too far or too fortified to escape the reach of modern warfare. Now imagine stepping inside this refinery before the attack. Inside, the environment is a highly orchestrated network of machinery, steel pipes, valves, pumps, and control systems. Distillation columns tower over multiple levels of platforms connected by metal stairways and catwalks. The air carries the scent of hydrocarbons, lubricants, and chemical additives. Operators in flame-resistant uniforms monitor gauges, digital screens, and flow indicators from centralized control rooms. These control rooms are the brains of the refinery, where temperature, pressure, and flow rates are continuously monitored and adjusted. Complex chemical reactions occur in catalytic cracking units, hydroprocessing systems, and desulfurization plants. Tanks hold intermediate products waiting to be refined further or blended into commercial grades. Boilers and heat exchangers move massive amounts of thermal energy to ensure crude oil components are separated efficiently. The entire interior is a living, breathing organism of industry, one that relies on balance, precision, and safety protocols to avoid disaster. When the Ukrainian drone struck, this delicate balance was violently disturbed. Explosions ripped through sections of the refinery, shattering pipelines, damaging control systems, and throwing the entire plant into emergency mode. The interior, once filled with the steady hum of machinery and the glow of operational lights, was suddenly chaotic, darkened by smoke, illuminated by fires, and filled with the hiss of leaking gases and the roar of burning hydrocarbons. Workers scrambled to execute emergency shutdowns, activate fire suppression systems, and evacuate endangered zones. Emergency lights flickered, alarms blared, and radio communications buzzed with instructions, warnings, and calls for assistance. In this moment, the highly engineered interior revealed both its sophistication and its vulnerability. Redundant systems kicked in to prevent a total catastrophe, but not all could be saved. Some units were isolated successfully, while others burned uncontrolled until firefighting teams managed to contain the blaze. The human element, courage, quick thinking, and adherence to protocols, played as much a role as the machines themselves. Performance under such conditions is no longer measured by output or efficiency, but by resilience. How quickly the refinery can shut down safely, how well it can prevent escalation, and how effectively it can minimize damage. Before the attack, this refinery's performance would have been impressive, processing tens of thousands of barrels of crude oil per day, producing high, grade fuels, maintaining export commitments, and generating significant revenue for the Russian energy sector. But during the strike, its performance was judged by its ability to survive. Drones, small yet powerful, slipped through or overwhelmed the refinery's aerial defenses. Anti-drone measures such as radar surveillance, jamming systems, or kinetic interception either failed to respond in time or were insufficient against a coordinated swarm or precision strike. As explosions tore through critical units, emergency systems tripped. Valves closed to isolate ruptured segments, pumps stopped to prevent backflow, and flares ignited to burn off excess gases safely. Production ceased almost instantly in affected sections, and nearby operations were suspended to prevent cascading failures. The performance metrics after the attack dropped to zero for the damaged units, while others operated at a fraction of their capacity. Repair assessments began immediately, but downtime stretched from hours to days and likely into weeks for full restoration. Each day offline represented millions in lost revenue, disrupted supply chains, and increased strain on other refineries in the network. Safety is always a paramount concern in facilities that handle flammable, toxic, and high-pressure substances, and the Ryazan refinery was no exception. It was equipped with multiple safety layers designed to prevent, detect, and mitigate accidents. Fire suppression systems, foam and water deluge cannons, gas detectors, pressure relief valves, blast-resistant control rooms, and emergency evacuation protocols. When the drones hit, some of these systems performed as intended. Alarms triggered evacuations, firewalls contained initial blasts, and suppression systems limited the spread of flames in certain zones. However, the sheer force and precision of the drone strikes likely overwhelmed localized defenses. Power outages or damage to control circuits may have delayed or disabled certain safety responses. Firefighting teams from both the refinery and municipal services raced to the scene, battling intense heat, potential secondary explosions, and the constant risk of toxic smoke. Their ability to contain the fire prevented what could have been a far worse disaster. But the incident also highlighted gaps, whether in aerial defense integration, redundancy of suppression systems, or the physical hardening of key units. The strike proved that safety planning must now consider aerial attacks not as rare anomalies but as plausible scenarios in conflict zones. What makes this incident unique is how it exemplifies the changing nature of modern conflict. In the past, wars primarily targeted military installations, front lines, and strategic troop movements. Now, the battlefield extends deep into civilian and industrial infrastructure, particularly energy facilities that fuel both economies and military machines. The use of drones, relatively inexpensive, hard to detect, and capable of precision targeting, represents a shift in warfare tactics. It allows a smaller force to impose disproportionate costs on a larger adversary. The Ryazan refinery was not just an oil plant, it was a symbol of Russian energy power and a crucial element of its wartime economy. Striking it sent a message far beyond physical destruction. It demonstrated vulnerability, undermined confidence in domestic security, and forced a reallocation of resources to protect similar assets across the country. For Ukraine, the strike served both tactical and psychological purposes, showing reach and capability. For the world, it was a case study in the intersection of industrial operations and asymmetric warfare. The cost of this event is multidimensional. Direct financial losses include the destruction of physical infrastructure, distillation columns, heat exchangers, pipelines, control systems, and storage tanks. Each of these components can cost millions to replace, not to mention the labor, materials, and time needed for repair. Lost production during downtime can reach tens or hundreds of millions, depending on the duration and scale of the outage. Insurance claims will surge, premiums for refineries in conflict-prone regions will rise, and investors may hesitate to fund upgrades or expansions. On a broader scale, the price includes market disruptions. Fuel prices may spike due to reduced supply. Downstream industries may suffer shortages, and neighboring countries relying on Russian exports may face logistical challenges. There is also an environmental cost. Burning hydrocarbons release greenhouse gases, particulate matter, and toxic compounds into the atmosphere. Firefighting runoff can contaminate nearby waterways and soil. Communities near the refinery may experience health risks, evacuation disruptions, or economic fallout if jobs and services linked to the refinery are paused. On the human level, injuries, trauma, and the risk faced by emergency responders add another layer of cost that is harder to quantify but deeply felt. As we look at the broader implications, this drone strike is not an isolated event. It is part of a pattern emerging in modern conflicts where infrastructure is targeted to weaken an opponent's economic backbone. Energy facilities, power grids, data centers, and transportation hubs are all becoming potential battlegrounds. The Ryazan attack will likely push Russia to invest heavily in counter-drone technologies, hardened infrastructure, and decentralized energy networks. It will also push other nations, both allies and adversaries, to study and adapt. Could refineries be redesigned with more underground piping, reinforced roofs, or automated drone interceptors? Should control rooms be relocated off-site with remote operation capabilities? Is it time for the energy industry to adopt military-grade surveillance and defense measures as standard in strategic regions? These are the questions that incidents like this bring to the forefront. The conclusion of this story is both cautionary and forward-looking. The Ukrainian drone strike on the Rosneft refinery in Ryazan is a stark reminder that the boundaries between military and civilian, between frontlines and hinterlands, are blurring. Energy infrastructure, once considered safe deep within a nation's territory, is now exposed to precision attacks from hundreds of kilometers away. The event revealed vulnerabilities in performance, safety, and resilience, but it also illuminated pathways for improvement. The future of industrial security will likely involve smarter, more adaptive systems, artificial intelligence monitoring airspace, autonomous repair units, modular and redundant plant designs, and international regulations on protecting civilian infrastructure during conflict. For Russia, the price of this event will be paid in reconstruction costs, lost revenues, and a renewed urgency in energy defense. For Ukraine, it represents a demonstration of capability and a strategic message. For the world, it is a lesson in how technology and strategy are reshaping the theater of conflict. Thank you for watching this deep dive on Channel Future Force. If you found this analysis informative, make sure to subscribe, like, and comment your thoughts below. Stay tuned for more updates as we continue to bring you the most comprehensive and detailed breakdowns of global events, technology, and security in the modern era.